Okay, the diagram shows two similar ice cream cones. The area of the circular end of the larger cone is 22.7. Okay, so this area here. The volume of the larger cone is 84.6. The area then of the circular end of the smaller cone is 15.2. So they want us to find the volume of the smaller cone. Okay, so we need to find a scale factor. And the only way we can do that is if we've got a corresponding lengths that we can compare, or corresponding areas or corresponding volumes. And in this case here, you notice they give us the areas of the circular ends. We know both areas, so from there we can find the scale factor. So scale factor then is comparing these two. It's either going to be 15.2 over 22.7. That's essentially if we want to look at the scale factor in terms of it being reduced, okay, because the smaller numbers on top. Or if we're trying to make it larger, we'll write it the other way around, okay? And it's a case of determining, well, what are we asked to find out here? And we're told that we're asked to find the volume of the smaller cone. They've given us the larger volume, so we need to find the smaller one. So we want to make it smaller, so we're going to choose the smaller scale factor, okay? Now, this is interesting because this is referring to the area, yeah? So that actually is the area scale factor, okay? Not the length scale factor, not the volume scale factor. This is to do with the area scale factor. So that will equal to 15.2 over 22.7, okay? Now you don't need to even type that into your calculator. Yeah, you could just leave it like that, okay? But we want the volume scale factor, yeah? But we just need to appreciate that the order of events here in terms of like, well, we start off with length, then we have area, then we have volume. So to go from length to area, you have to square. Or to go from length to volume, you have to cube. But if this is where you're at, if you're at area, and that's where we are at the minute, what we need to do is we need to go back to length. And then once we're at length, we can cube it to get the volume. But you just need to appreciate the order of events, isn't it? Because if we knew length, you need to square it to get area. But we actually know the area scale factor. So to work back to get the length, we're going to have to do the opposite of squaring and square rooting. So the length scale factor will be the square root of this. Okay. Now this might be really nice. Okay, it might work out really nice, but I'm not even going to bother type it into my calculator yet. I'm just going to leave it as it is. And appreciate now that's where I'm at. I'm where I need to be. In my second step, I am here. I'm at the length scale factor, okay? But now I want the volume scale factor. So if I got the length scale factor, I need to cube it to get the volume scale factor. So I'm going to cube it. So I'm going to cube all this, and I will get the volume scale factor. So whatever that is, maybe we put in a bracket cubed. So that's the scale factor that I'm going to need. So I'm going to just take the volume of the larger one and I'm going to times it by this here. So all I need to type into my calculator is this. So let's do it. So I've got bracket square root fraction 15.2 over 22.7. Let's get out to there, close the bracket. I'm going to cube it, and then I'm going to press times 84.6, and it should come out to me then with my answer 46.355 or 36, two decimal places, centimetre cubed.